Hi everybody. So today we are going to discuss a question which was asked in JEE Advanced 2024. A very good type of question which is not yet asked for CSIR-NET or GATE. So this is a very good model that I liked personally. So let's try it out. Consider the kinetic data given in the following table for the reaction A plus B plus C giving product. So set of experiments are given, changes in the concentrations of each of these reactants are given, and the corresponding rate of the reaction is also given. You have to find the rate of the reaction for a concentration of A is equal to so and so, B is equal to so and so, C is equal to so and so, where the rate is Y into 10 to the power minus 5 moles per liter per second. The value of Y is. Okay, so let's try this out. First of all, we need to find the order with respect to A, with respect to B, and with respect to C. For that, we'll be comparing any two experiments. For example, I'm comparing 1 and 2. Now, there are a lot of ways in which we can do this. Okay, so I'll be explaining the one which requires the least time. Okay, so let's say I compare 1 and 2. So if I compare 1 and 2, my concentration of A is not changing. My concentration of B is doubling and my concentration of C is also not changing. Okay, so what I can understand from this comparison of experiment 1 and 2 is by keeping the concentrations of A and C constant and only doubling the concentration of B, I can see that my rate of the reaction is the same, correct? So even though I have doubled the concentration of B, my rate has not changed. My rate has not changed, and hence it means that doubling the concentration of B has no effect on the rate of the reaction, and hence it is a zero order with respect to B. Correct? It's a zero order with respect to B. Now let's compare any other two experiments. For example, I compare 2 and 3. Hmm? Now, if I compare 2 and 3, again, there is no concentration changes in A. In B, the concentration is halved, but then it does not matter, correct? As it is a zero order reaction, even if you double, even if you triple it, even if you half it, it has no effect. So considering B is of no use. Okay, it makes no sense. So this need not be considered. And if you can see, concentration of C is doubled. Okay, this has no effect. This has got no effect. And this is kept constant. Correct. So now we get a relation where the concentration of C is doubling and the rate is also doubling. Correct? The rate is also doubling. So in that case, what we can say is if the concentration of C doubles, rate also doubles, means it is first order with respect to C. It is a first order with respect to C. Correct. Now next. Next I want to, so I have already got the order with respect to B, I've got the order with respect to C, and I need an order with respect to A. I need an order with respect to A, for which I need to choose the experiments in such a way that the concentration of C does not change, because the concentration changes of B though won't matter because it is zero order. So the concentration of C is kept constant. Let's say I take 1 and 4. If I take 1 and 4, my concentration of C is kept constant. B though does not matter, but still it is also kept constant, and my concentration of A is changing from 2 to 3, 0.2 to 0.3. Okay, it's changing from 0.2 to 0.3. That means it is changing by 1.5 times, correct? It's changing 1.5 times. And what is happening to the rate? If you look at the rate, it is changing from 6 to 9. That is also 1.5 times. 9 by 6 is also 1.5 times. So it is first order with respect to A as well. So now you have got the order with respect to A, which is equal to 1, with respect to B, which is equal to 0, and with respect to C, which is equal to 1 again. Okay, now let's see how to proceed with the question. You have to find the rate of the reaction when concentration changes are so and so. For example, you can take any experiment. Let's say that I'm taking experiment number 4. I'm taking experiment number 4. So when experiment number 4, you can take any experiment, okay? My concentration of A is 0.3, concentration of B is 0.1, concentration of C is 0.1, and my rate of the reaction is 9 into 10 to the power minus 5. Now in the question, what they have given us, let's do it step by step. In the question, they have given that you have to find the rate when the concentration of A is made to 0.15. So from 0.3, if I reduce it to 0.15, I know that with respect to A, my order is 1. And if I reduce my concentration of A by 1 point, no, by 0.5 times, this is halving, correct? You're making it into exact half. And being a first order reaction, your rate will also be reduced by half. So your new rate is going to be 4.5 into 10 to the power minus 5. Okay, so that is the effect that is caused when you change your concentration of A from 0.3 to 0.15. Now I just took experiment 4. You can take any experiment, you're going to get the same answer. Okay. Now, so that was my first step. Now, concentration of B is made to 0.25, 0.25 moles per liter. But you know that whatever concentration changes you make for N, that's not going to affect the rate. Why? Because it's a zero order reaction. So again, your rate is going to remain the same. It is 4.5 into 10 to the power minus 5. Okay. Next, C. Now C, it was 0.1 and you're going to change to 0.15. Correct? Now this change is you have increased the concentration 1.5 times. And being N is equal to 1, so it is a first order reaction. So whatever changes that you bring in concentration is going to linearly reflect in your rate as well. So here also your rate will change by 1.5 times. Correct? Because the concentration has changed from 0.1 to 0.15. 0.1 to 0.15 is a change which is brought by 1.5 times. Correct? How do you find that? 0.15 divided by 0.10 is 1.5. Correct. So now your rate has changed by 1.5 times, which means 4.5 into 1.5, and you get a new rate which is 6.75 into 10 to the power minus 5 units. Correct? Now what is the question? You have to find the rate, which is Y, into 10 to the power minus 5 moles per liter per second. And you have got the value of Y as 6.75. Okay? So the correct answer to this question is 6.7. It's a very easy question and it is conceptually built. Okay. All right, so see you in the next. Bye-bye.